Alright, so I want to give you some examples from the 6-1 lesson that I gave you the other day. This is actually the second lesson that we do in class, but I've just selected a few examples out here and I want you to practice them if you haven't done so already. Number 4 here says, find the sum of all the angles in a 12-sided figure. So to do that, we're going to go back, and remember, this does not matter if it's regular or not. It's 12-sided. A 12-sided figure is always going to add up to the same thing. We're going to say 12 minus 2, that gives me the number of triangles. And so 12 minus 2 gives me 10. I know each triangle has 180 degrees in it, so 10 times 180 gives me 1800. That's how many degrees are in a 12-sided figure. So if I look, I'll draw a 12-sided figure. That's a 12-sided figure. If you take this angle plus this one, go all the way around, it's going to add up to 1800. And that should make sense. These are very big angles here. They're all greater than 90. They're all up to almost 180. So you got 12 of them. It's going to be a large sum when you add them up. Let's see. Let's go to a different one, different directions here. It says find the measure of one angle in each regular polygon. So the directions are telling me it's a regular polygon. Whoops, not our 12-sided polygon. Thought I had my pen. It tells me it's a regular polygon. We've already done a 5-sided figure. You can go back and look at the notes for that. I'm not going to do that one again. Let's look at this one. This is a regular 15-gon. Let's see if I've got a drawing for that. I think I do. It's a regular 15-sided figure. That's what it looks like. We want to know what is the measure of one of those angles. So we're going to take and say, first ask the question, what do they all add up to? If I added up all of these, what would I get? And so I want to know how many triangles are in that thing. So 15 minus 2 gives me the number of triangles. That gives me 13. That means if I started right here at this corner and drew a line to each corner going all the way around, I'd get 13 triangles. And each triangle has 180 degrees in it. So 13 times 180 gives me my sum. That's 2,340. That's what all the angles add up to. Well, I've got 15 of those angles, and each one gets an equal slice of that 2,340. So divide by 15, and you get 156 degrees. That is the measure of an interior angle there. Let's skip along to the next one. So this one wants to figure out what is the value of x. Now notice this is not a regular figure. But what I can say is that while it's not regular, I know that they all must add up to the same amount. Let's see, how many sides this got? It's got 1, 2, 3, 4, 5, 6, 7. I just counted the number of angles. That will equal the number of sides. So what's the sum of a 7-sided figure? It's going to be 7 minus 2 times 180. So 5 is how many triangles it has. 180 degrees in each triangle gives me 900. I know that all of these must add up to 900. So I've got 1, 2, 3 of them are x's, so 3 times x, plus I've got 1, 2, 3, 4 are x plus 50. So 4 times x plus 50, all of that gives me 900. Make sure when you do this that you distribute correctly. 4 times x gives me 4x. 4 times 50 gives me 200. And I'm going to subtract 200 from both sides, and I'm also going to combine my like terms here. I get 7x equals 700, where x is equal to 100. Let's see, all of these are very similar, so I'm not going to do that again. Let's see here. It says find the measure of an exterior angle of a regular polygon round to the nearest tenth. So keep in note a couple of key words here. We're looking for the exterior angle on this one, and it's a regular polygon. What does that tell me? It tells me I can use NE equals 360. We can only use that equation if it's regular. And if you're wondering where I got that equation from, go back and watch my 6-1 video. So this says a decagon. What is a decagon? It's a 10-sided figure. Now you don't need to draw these, but since I have the computer tools to do it, I want you to kind of start to see what they look like. That's what it looks like, a regular decagon. And they want to know what is the exterior angle. So if I were to draw this and it's like I forget to stop and turn right here. This is my exterior angle. I want to know what that measure is. So I can put in, I know the number of sides. I can just write in, hey, I know n is 10. I don't know the exterior angle, but I know when I multiply them I get 360. Divide both sides by 10 and you get the exterior angle is 36. Let's do another one. Let's do a 72gon. Now that's one I can't draw because I don't have that on here. But what I normally do is when I'm trying to sketch it out, I just do this. Okay, here's one interior angle of a 72gon, and then there's the rest of it. I just kind of draw a dashed line like that to say, hey, yeah, there's like 72 total sides here. Right here is my exterior angle. That's what I want to know. So I'm going to use, once again, since I know it's regular, I can say NE equals 360. I know it has 72 sides. If I times that by E, I will get 360. So 360 divided by 72 gives me 5. So the exterior angle is 5 degrees. So this isn't drawn to scale, but that's okay. And I can also, remember, I can figure out what the interior angle is because I know they're supplementary. 180 minus 5 gives me 175 degrees. So 72gon is going to have a very large angle right here, almost 180. It's going to look like a straight line almost. Let's see. Trying to find a few others in here that might be helpful. We might go on with the lesson we were given. So let's start with this one. A lot of times the SOL likes to ask you questions like, Johnny was working on his homework and he had a regular polygon on the paper. He spilt some paint on the paper, covered up the polygon. He remembered it was regular, but he couldn't remember how many sides it had. Well, I try to be a little more creative in the classroom. We always talk about like a student with a backyard and a regular polygon in their backyard, and like a giant flower lands on their back patio. They remembered their back patio was a regular polygon, but they couldn't remember how many sides it had. The exterior angle they measure was 60 degrees. How many sides did it have? So it's another way of asking the same question about exterior angles on a polygon. We know that if it's regular, and the problem should state that it's regular so we can use this formula, is that NE equals 360. What does N stand for? The number of sides. What does E stand for? The exterior angle measure. And then we know that all the angles will add to 360. So if the exterior angle is 60, we know the exterior angle in this case, and we'll put 60 in for E, and then I'm going to solve for N to figure out how many sides it has. Divide both sides by 60 and you'll get N equals 6. So it's a 6-sided figure. If I take this thing off, you'll see that, boom, 6 sides there. Same question. We know that we've got a regular polygon behind this big heart right here. We know the exterior angle is 9 degrees. How many sides does it have? So pause the video, give it a try. So once again, since it's regular, we can use NE equals 360. The exterior angle measure is 9. The number of sides is not known. Divide both sides by 9. Let's see here, 360 divided by 9 gives you 40. So it's a 40-sided figure. And I don't have a 40-sided figure drawn behind there. It's just part of the problem there. Just pretend like it's 40 sides back there. Now let me ask you a question. See if you can get this right. What is the interior angle measure? Well, I know that these two right here, they form a linear pair. So that means they add up to 180. So this isn't drawn to scale. A 9-degree angle doesn't look like that. But if these two add up to 180, then I can say 180 minus 9 gives me 171 degrees. So that's the interior angle measure here. Okay? There's two ways you can figure that out. You could also say, what do all the angles in a 40-sided figure add up to? And then divide it by 40. I think this way is a little bit easier. You can do either method you want. Okay? Hope that helped. Like I said, if you didn't quite catch on what was going on in any of these examples, or even just a few of them, it's a little bit of a longer video. Go back and watch my 6-1 video as an introduction to the angle sums in a regular polygon and irregular polygon, and also the interior angle of a regular polygon and the exterior angle of a regular polygon. I've got a video that explains all of that. These were just sample problems from the homework to kind of give you some examples. Thanks for watching and hope this helps.